and conduct capacity building on the same. For this particular presentation, are you able to see my screen? I don't know if you're able.
Yes, Rose, we can see you now, live and direct.
Aha, great. So my colleague Angela Cho has not joined yet. I acknowledge her input into this particular work. So what we did is, this is basically, I will share the presentation after, but these are the steps that we took in, within the notebook, within the DA platform. I must say that we have attended both at we've completed the masterclass, and this gives us the opportunity for us to basically showcase what we are doing. It's because of our, participation within the review of the masterclass, but also doing the entire masterclass. I would urge everybody to just take some time to complete everything. There are good things inside there, but we looked at agriculture within Kenya, and most of it, the staple crop is maize in Kenya, and we decided to pick one of the administrative units is like a ward. And what we did is we were able to analyze Bridge. It's in Soy sub-county in Uasin Gishu County in Kenya. And this particular ward, we took it because we have the National Cereals and Produce Board having their silos. You can see the same on your way to Uganda. I see there was a participant from Uganda, right? So on your way, as you see the silos, and this is why we just chose it, just to see a quick assessment of the same. And the dimensions of the exact location are within the slide, the latitude, the longitude, the buffer. We decided to work with 0.2 so that we can at least blow the area up. Like I mentioned, the predominant crop is maize. And one of the things that we were keen on is to be able to establish the trends, but also we didn't want any effect with the cloud. So we within the notebook, we have the clouds are masked out. So that particularly helps, especially when we are talking about averaging, because if we take values that have clouds, they have very low NDVI, then we can have a false change, so to speak. In the assessment, we were able to generate the map that you can see. So here, when we did kindly stop me at any point should you have a question on what I'm presenting. So we looked at the NDVI climatologies and doing the calculation, we have the graph that you're seeing where we have values from 0 to 1. Of course, already the values that are not, the areas that are not vegetated are not, so to speak, considered in the same. So we are just picking the areas that have the NDVI value of 0 to 1. My assumption is that everyone on the team understands the normalized difference vegetation index and the role it plays in terms of assessing vegetation. So the mapping of the clear pixel is made so that we can understand what are the observations that are within the NDVI, just so to understand the trend. And then when we do the average for the conditions, we are able to do an estimation of the typical conditions for the next step. So it is stepwise, it is a stepwise process that enables us to understand what is happening on the ground. And the reality of it is that it's not possible for us to have, it is possible, but it is quite time consuming for one to download all the images and then do all the NDVI and then like extract values to points. So this makes it a bit simpler. Like you can be able to assess the entire period because we're working from, we decided to work from 2010 to 2020 and the base to be 2021. So that at least narrows down the information. And also why we did that is that we wanted to assess in 2021, December 2021, what is the performance in comparison to the data between 2010 all the way to 2020, just to see the deviation. And then, we did the standardized anomalies, and here we were calculating the long-term NDVI and the standard deviation. So what this basically means is that what is the amount of deviation? Like if you do the average, how much of that, what is the value what is the difference between the average and what is being visualized. Then we did the mean, we did the standardized anomaly, and this was done by subtracting the long-term mean and dividing by the long-term standard deviation just to assess the, this is what is done behind the scene in the background. What we see is what is in the output. And then the beauty of it is that the products, they are plotted, and the time period, sometimes if you take our observation was that if you take so many years, it takes a longer time to calculate, because, for example, we are looking at entire, say, since we are using Landsat, we have each and every month or two images within a month, say first and the last day of the month, and then calculating all the way, say, if you're taking 2010 to 2020, that's about 10 years. So if you take from 1984, of course, you are looking at a bigger duration. So we did, RCMRD indeed had developed a crop mask before. So this particular crop mask, since I'm going to share the presentation, if you look previously on the top right, you see like there are no, it's dark, meaning there are no vegetation there. And maybe if I can take you back quickly to this particular Google Earth image, if you notice the bounding, the red bounding box, on the top right, we have a forested area. So one, despite the crop mask being a bit older, we are able to trace this, that these areas have already been masked out. So these areas are the areas that do not have cropland. Then the yellow are the areas that have croplands. So loading the crop mask over the buffer area, which is the bounding box, and RCMRD has contributed to the validation of the current, like the current crop for the eastern side. And like I mentioned on the similarity, so plotting, I think you have seen, I've put like a small image there on patience. So here, the reason why I put the patience is because you need to be able to look at the notebook when you're running each and every script. What happens is that at the end of each successful run, you have a number being displayed. So as long as it has an asterisk, it's important to note that the process is still ongoing. So you have to be patient. And then, like I mentioned, when you're working with so many years and you're going to plot this data, it will take more time than if, for example, you're just assessing 2 years or 3 years. So the more the number of years, the more the patience, so quote unquote, that you will need. So here the plotting was only for the cropping regions. So we are doing the mean NDVI, the seasonal mean, and the anomalies. So for starters, I think the slide will not show very well, but you can tell, one, even from the average mean, the areas that are not having crops have already been masked out. So we are just dealing with the cropland areas. And there's also a difference. If you look at the mean, there's a difference within the mean. If you look at the standard deviation, you can also see the mean is the average of the NDVI for the entire time period. So the first plot, the first graph, that is what you're seeing. In the second, we are looking at how much the December NDVI values differ from the mean NDVI of the time period. So we have the entire mean for all the years that we have selected, and then we have the December NDVI values. How much do they deviate from the mean that is there? So this basically is the key observation that you're already making. Number one, if the mean is low, you understand that probably maybe 2 or 3 years there was some drought or a reduction in the rain or an excess in the rain. So that covers the mean. But then when we talk about the NDVI, you are able to see in December what is the difference in December versus the entire time period. For the third graph, this is the average of the NDVI for 2021. So you can see it's not really similar to the mean of the entire time period, but there is some slight similarity, especially if you look at the bottom right area. So we have lower values in that particular area. So one would ask, is it within a different agroecological zone? These are some of the questions that you ask yourself. Huh? Is it within a different agroecological zone? Is it that there was, you don't want to, assume and say like, oh, this area is a bit lower than the other, because you'll need more data which we are going to talk about in the next slide, but also is there any possibility? What is the driving for these lower values in comparison to the other? Then in the last slide, we are having the December NDVI values differing from the mean NDVI of 2021. So one thing to note about Kenya is that we have some area, we have different agroecological zones. Of course, the northern side of the country is much drier, and the western part of the country, which is our chosen area to evaluate, is like the food basket of the country. So that being the case, some areas we have 2 rainy seasons, of course, with climate change, some slight changes. But like right now, February should be the start of it's quite hot right now, even in Nairobi. But then at the western side, you might find some areas that are just completing, like they're about to get into the planting season for the maize, and sometimes you might have mixed cropland. But then here in this particular last plot, we are looking at how much the December NDVI values differ from the mean. But then again, one of the assessments, and this comes with your understanding of the area. So any area that you pick that you want to evaluate, you need to have an understanding of that, some more knowledge, not just specific, just using the Earth observation data and that's it. So this one, we are looking at Landsat data. Remember, we have the climatic data, and then we have the information on the ground. So from my understanding of the western part of the region, we might have the lower values. It's quite deviating, especially since we picked December, because by that time, harvesting has already been done. Okay, so this can explain, and this is an assumption unless we get now the specific date, we got to more in-depth analysis. So what were our observations? The first is that the seasonal NDVI mean does not greatly differ from the long-term mean of the NDVI. And this is within the, remember the side is within the western part of the country. And then for the cropping regions, they have higher standard deviations in NDVI. So what we are asking is, could it be seasonality? Because we are considering the entire year. Is it that you need to specify and have like if we have the crop calendar, like the maize crop calendar that can be given by the Ministry of Agriculture, but getting to narrow down, this is the average and we're talking about the entire year. So from the script, you can be able to edit and give specific months within the year that probably this is the planting season, this is the maturity date, this is the crop calendar differs in different areas. So for us, we are looking at maybe it could be seasonality. We are not sure about it, but with our knowledge of the area, yes, in December, they have already harvested. The crops in December, the crops are worse than average. Of course, they have already been harvested. And we have some areas that have as high as 2, while others have like -2. So I think depending on the composition of who is in attendance, when you're harvesting maize, unless you've not harvested maize in the past, you get rid of the cob first, okay, unless you are harvesting the green plant for forage. But then if you're harvesting for grain, you wait for it to dry. It's cheaper for you to have it dry on the cob first before you do the harvesting. But then you have the stalks remaining for a while, and then they will also be removed, or they'll be incorporated into the soil as mulch or something of the sort. So the different ways, because we're having small parcels of land and people are doing different things on the land. However, if you want to assess, you can edit your bounding box to assess just one particular field, like it should be at least sizable enough. Then probably you'll be able to look back and know what activities was done, and you can be able to explain more about the values. Then climate data can also confirm the drivers of the change. So maybe at that particular, in one of the areas I mentioned previously, there could be some reduction of rain or an excess rain or something of the sort. So we can tie in climatic data here, and we are able to explain further on the NDVI values that we are seeing. Yeah, the masking, like I mentioned. So what is the way forward? The products are able to calculate like on the fly. Maybe within 3 or 4 hours, we had all this data ready. And then there's a bit of ease in identifying crop performance from the previous years because of the NDVI. Of course, we are looking at the NDVI is the the green, like looking at the chlorophyll content of the plant. So you can be able to assess maybe if it is within the same, we are having the same crop calendar, we're having the onset, the planting season, harvesting being already defined, we can be able to quickly assess. Then, of course, we can link in climatic influence on crop performance, of course, at different stages. And maybe I should say that we're just talking about first maize because that is the predominant crop. But at different stages of maize, the moisture requirements of the maize is different. At the planting season, when the maize is at the knee high, the amount of water it requires, and also the application of fertilizer. So this is not even considered, but that is also a way. There's a difference in which the maize will appear, say on the satellite image, depending on the growth stage of the maize. Then, of course, looking at this result, we are thinking of we already have a program here at the center, and we're looking at how this can be incorporated into some of the already processed data. So for example, instead of us, downloading all these images, we can quickly pinpoint of the areas that are more having one where it's maintained, the NDVI is more or less having a constant trend. And then we have areas where are quite it's really dropping. We quickly assess the image, we are able to do some level of stratification to understand, and also we are able to get, say, ground control points in the same. Then one is that moving on, instead of, we are able to incorporate this into the capacity building, especially if we consider the Ministry of Agriculture as one of our end users of the products that we generate. So if, should we get an opportunity to have a training session, of course, they'll be very happy to assess a wider array of images rather than just the same year, like we are assessing, say, what we have derived in January, and not being able, or being very time consuming for you to assess that January and the entire, say, if you want to check 20 years back. Okay, thank you, Dr. for posting the dashboard and the anomalies. Yeah, the script. Asante, meaning thank you in Swahili.
Thank you, our teacher today, Rose Waswa from Regional Center, a senior remote sensing analyst. Do you have any questions for Rose today? Please feel free to use your microphone. Thank you very much, Rose, for this great presentation. At least you gave us some phenology information about maize, farming of maize, from harvesting to replanting, and this could be a similar experience with other partners in the continent. Would you have any questions for Rose? Please feel free to ask.
Should I go first? This is Emmanuel.
Please. Yes, please.
Rose, thank you so much for the presentation.
You're welcome.
And a quick one, I just wanted to know how you segregated the crop, the maize field from other vegetation cover, and what is the influence of the other vegetation cover and other cover crops to the result that you have presented today. Thank you.
Thank you, Deng, for your question. No, the results that I'm presenting is not segregated or specific to maize. Maize is the most common crop grown within the Western region. I'm afraid the differentiation between maize, whether it is intercropped with other crops or just a standalone, is not yet, we are not yet able to do that. But we are actually doing some research on the same, but then of course we cannot do it for the entire country. So no, the results is for all crops that are grown within Western, with a bias to maize, because maize is the one that is grown in majority of the farmlands. So okay, what I envision is that since we are able to assess that, we are not limited to the extent that we can be able to do the processing. So if you can narrow down to a large plot of land, then which you have details or information on the same, then you can be able to know whether it was just one of the crops grown or if it was mixed, then you can be able to compare.
Sure.
Okay, thank you.
Because I thought there was you probably segregated into different land uses, or maybe within the agriculture and have different crops. Then we narrowed to maize fields basically.
Oh, the segregation in the land uses is there's the import of the crop mask. So the crop mask has omitted all other land uses except for the cropland areas. That is and that had already been developed.
Okay.
So it was simply importing that and then masking out all the other areas. Yeah, all the other areas that are not cropland. So the values that we are getting are simply for the cropland areas only.
Okay, thank you. Thank you.
You're welcome.
Thank you very much, Rose. And also Rose, they did some field work, so they could also have some more field information in terms of the GPS coordinates and information from some of the farmers.
Yes, yes. So that's why we say the majority of the crops are maize based on this information.
Thank you so much, Rose, for this great presentation. If there's any information or question for Rose, I've put the email for Rose in the chat for further contact. Otherwise, any other update from any of you? Wish to welcome Dr. Kelibogi to this meeting. She's calling from Botswana and she's done some great work on the Okavango. As today is part of the Wetlands Day, perhaps she can share something about her work if she's comfortable.
You caught me unaware, but thank you so much. I just come back to work yesterday. You know, I've been on a long Christmas break because we worked so much for the whole of 2021 using the Digital Earth Africa platform, as Kenneth has just mentioned. We actually managed to work on water extent and changes that are happening in our wetlands. And when I say wetland in Botswana, I mean the lake and the real floodplains and the marshes that you find in northern Botswana, because much of the country is dry. So, but we do have wetlands that are actually important internationally, like there are Ramsar sites, and there are also the Okavango Delta, as some of you may know, is a World Heritage Site. So we are a dry land, but we have important wetlands also internationally. And I'll just maybe you can look at what we've done in the blog that is available on the Digital Earth Africa. We actually assessed water extent in Lake Ngami, which is a wetland that is found in the northern Botswana, and it's an endorheic wetland. So it in most times it is covered with water, but also in other parts of, like in decades, it can go dry. Like there are some people that were living like until they were teenagers in the 80s, they didn't see it inundated, but then in the 90s, it started to getting water like beginning of the 2000s, and then at the end of after 20 years, like in the 2019, 2020, it started drying out again and it's filling again. So there's a lot of dynamics happening in our wetlands. Maybe because we're in the dry land, you cannot say we have permanent wetlands, like in other places you have permanent lakes and rivers, but we only have two actually permanent rivers that are international also, like transboundary, like the Okavango and then the Zambezi, which are in the northern part of the country. So the Lake Ngami, as you see it there, you can see how the water was actually diminished or in extent. It actually reduced in extent from being fully flooded or fully inundated to being like maybe like 30% full by 2021, even up to now. It's not really recovered from. It was because of the drought that we had in 2019. It was a historic drought that happened, and we discovered that it actually coincided with the climatology data, which Rose actually also worked with, like rainfall data. We used the rainfall data over the years, over the last 20 years, and it shows that what is happening in the lake is actually a reflection of what is happening in the climatological aspects in terms of rainfall in the region. Not because, you know, as I said, we don't have permanent water, so it's regional climatology, like covering Namibia, Angola, Zambia, and Zimbabwe. This is where our water comes from. It's not coming from one country. So that is how peculiar we are in terms of wetlands and in Botswana. And I was not aware that today is the wetland day. So yeah, you can go into that blog, and then you can, it's in the Digital Earth Africa platform, and then you can look at what is happening in terms of what extent in the Lake Ngami. And it is actually an environmental indicator. I know people are used to using plants and animals as indicators, but from a geographical perspective, it's an environmental indicator. You can actually assess and monitor it to actually establish what is happening in the environment in terms of rainfall and water. So that is all I can say. As you see there, you in this animation, we can actually see what is happening within the recent times in the Lake Ngami. This is our environmental indicator. Thank you, Arthur. I don't want to take all of your time. I think, thank you for giving me this platform to say a few words on what the work that we are doing. And we want to use the Digital Earth Africa platform actually for monitoring what is happening in terms of the state of the environment in our wetlands in Botswana. Thank you so much.
Thank you, Dr. Kilebugi. I actually saw it today as well on the Al Jazeera just before this workshop, and I realized the work you're doing is of interest to many scientists, including also the Al Jazeera, who actually will document, will show some documentary, and very accurate as you've put it. Some communities have been displaced. They were even showing that when some farmers have lost cattle as well because of the muddy patches left, and the abrupt rains in the Angola in the June of some years sometimes is of interest. So it's very good to see and also share your blog with this audience to see what is possible after the presentation, which was done by Rose from RCMRD, and Dr. Kilebugi is from the University of Botswana. She's attached to the Okavango Research Institute, and she does some travels over 1,000 kilometers from here to here to the field